So far in Haskell, we've worked with simple types like ints, characters, and a little bit of work with strings. Of course, Haskell has a very rich type system. It's one of the things that makes Haskell such a valuable tool to have in your arsenal. And of course, we would have all of the types that we would expect to have in a mature programming language. We have things like bools, floats, doubles, and so on and so forth, and a lot of more complicated ones that we'll be getting onto later. In this lecture, I just like to have a little look at working with simple logical operations to define basic functions in Haskell. Now, of course, we have all of the operations you would expect. We have our ands, our ors, our nots, and the ands and ors take 2 booleans and return a boolean. Nots take 1 bool and return a bool. Now, of course, these work in the exact way you would expect. You're all very familiar with working with these operators, and the syntax in Syrup is not so different from the syntax in Haskell. Of course, Syrup was written in Haskell, so you would expect so much. So let's get started by defining a simple mux circuit. Now, I think all of you will remember what a mux is, but a mux is something that takes a control signal, 2 arguments, and depending on the control signal, will return one of the 2 arguments. Normally, we would return the first argument if the control signal is 0, and we would return the second argument if the control signal is 1. So we take 3 booleans as arguments, and we return 1 as output. So let's say mux takes a C, control signal, an X, and a Y, and then it does something. Now, normally the way that we would define this is to say, okay, when C is 0, we want to return X. So what will we do? Well, we'll say the negation of C and X, and that will return the X part of this argument, because of course if you negate 0 you get a 1, and if you AND that with another value you will only get the result of the other value. So how do we do this in Haskell? Well, it's very straightforward. Say not C and X. Hopefully this is starting something in your memory and you're thinking this is just Syrup, because it is. And then we do C and Y, and that's it. So it's very simple syntax, and it's exactly as you would expect it to be. It's exactly as you would have defined it in Syrup. It's just that we have double AND here and a double OR. This is because the single AND and the single bar are reserved syntax in Haskell for other things that we'll see later on. So if I go in here and I load in, I think I've called this booleans, and we load it in, let's try mux, and if it's a false value for the first one, so that's the same as being 0, then we should return X, which we'll call true, and otherwise we'll return false. In this case we should get true out as output, so let's see. There we go. Let's try changing the control signal. Let's make this true. That should mean that we get false out, because false is the second argument here. And there we go. So it's quite simple to define these things in Haskell. It's exactly what you would expect. It's not really very different from Java, Python, C. It's very straightforward. One thing I've mentioned up here, we have all of the other comparators you would expect, the greater than, less than, greater than or equal to, less than or equal to, and of course double equals to set equal to. We have all of these in Haskell. Now you'll notice I haven't given the type signature up here, and if you go into terminal, do Control T greater than, you can see that you get a little bit of a complicated type out. Now this is to do with something called type classes that we're going to get onto later on in the class, so don't worry about this now. Just instantiate this A with whatever you're working with. So in our case, let's say it's integer, you can just replace this in your head with integer to bool. Okay, and we'll worry about this OR day at a later date. So let's do a simple function here, which just says, is a number greater than 5? So let's say, oh no, we don't want to give it capital, more than 5, and that's just going to take one integer and return a boolean. And this could be a very simple function. Do more than, yep, there we go. We'll take an X, and we'll just say X greater than 5. And that's very, very straightforward. So remember, we don't need to wrap this in an if statement. In fact, that's something I'd like to see you avoid. But let's just run this quickly, and then we'll go back to that. If we reload, that's fine. And we do more than 5. Let's say we get 4 false and 10 true. So there we go. Now, as I was saying, you do not need to wrap this in an if statement. In fact, this is something I'd really like to see you avoid, is writing things like this. Now, of course, this is correct, but you don't need this. This is far, far too verbose for what is an incredibly simple function. If you look at the types of your functions, then you can determine what they will be when you give them arguments. So as we saw, this greater than takes 2 arguments and returns a bool. So if we give that 2 arguments, it will return a Boolean type. So we don't need to wrap that in an if to then get the Boolean out. We can just return whatever this will resolve to, and it will be a Boolean, so we don't need anything more than that. So that's something to try and avoid in Haskell. One thing that you might notice that's a bit odd is when we're using these operators, we write the arguments on either side. Normally, we write functions like this, where the leftmost thing is the function name. Here it's mux, here it's more than 5, and then we put the arguments on the right-hand side. Now, you might think that's a little bit odd, and it is a little bit odd, but this is something that's called infix notation, and you can make functions do this, so we'll have a wee look at how to do that next. It's worth noting that you don't have to use infix notation. It's just another way to maybe make your code a bit more readable, but it's entirely up to yourself. I'll show you how to do it anyway. So let's say we want to do a little function that says divisible by 5. 5 isn't particularly special, I'm just not very imaginative. And if we're going to check if a number is divisible by 5, we'll want to take an integer and then return a Boolean, because we're going to take the integer, see if it divides by 5, and then return a Boolean. So we'll take an x and that will be equal to something. Now, how will we do this? Well, one thing you could do is divide it and then see if the thing is rounded to 0, or we could use the modulus function. Now, you've all used the modulus function before. Modular arithmetic has formed quite a big part of your course so far. It's a very useful tool. And what it does is the modulus function takes 2 arguments and it divides them. It takes the first one, divides it by the second, and says, okay, what's the remainder when I divide this first number by the second? So if I do 10 and 5, that should return 0, because they divide, or 5 divides into 10 perfectly with no remainder. If I do 11 and 5, that should return 1, because when I divide 11 by 5, I get a remainder 1. So the modulus returns the remainder, as what I'm very long-windedly saying. Now, of course, we can go into terminal, and we can do that to see what the type of mod is. Again, we have something here which is a bit weird. Don't worry about that. Just think about this as being int to int to int. So it takes 2 ints and returns an argument. So what you might say is mod x5. That's one way you could write the modulus function out, and that would say return the remainder when I divide x by 5. That's how you would do that. But as I said, you can maybe write it like this in infix notation. Now the way you would do this is you would put x at the front, and you surround the function that you want to use infix notation with backticks, like that. It's suggesting that for me. And this says, okay, look at the arguments on either side now, and this might be a way that's a little bit easier to read. However, this will not return a Boolean for us yet, so what we'll need to do is say, is this equal to 0? So this is the double equals, this is the normal test for logical equivalence. So what this is saying is, if the remainder when you divide x by 5 is 0, then return true, else return false. Again, you don't need to wrap this in an if statement though. So let's load that in, do the little bit of reload, and we'll do div by, and let's say we do 15. Now 15 should return 0, and it should return true in this case. So that's good. If we do 16, that should return 1, which is not equal to 0, so we should get false. So there we go. So these are very, very basic functions. This is just to give you an idea of how you can write code using these simple operations in Haskell. Now, of course, one thing to take away from this video is using the terminal to help you find the functions that you need and their types so that you can better understand them. Also, the way that you should be trying to code in Haskell is writing very simple definitions like these. You don't need to use anything more complicated. You don't need to wrap things in if-then else's. You don't always have to use guards and pattern matching either. You can just write simple functions like this. And the way to write Haskell is to write it in the most readable way, the way that makes most sense to you, and the way that is cleanest and easier for other people to read. So you might not find that this infix notation that we've put around the mod function here is easy to read. It's up to yourself. This is just another way that you can use to style your code using Haskell. One thing that's worth mentioning, these backticks, they're on the top left of my screen. or on the top left of my keyboard. They'll be on a different place in your keyboard. It might be worth having a wee look just to find them. It's not like a quotation mark or anything like that. It is a separate character on your keyboard. It's known as a backtick. But yeah, that's everything for today's lecture. I hope you found this useful. As I say, it's very simple functions. It's just to get you into the mindset of writing simple functions in Haskell and some of the logical operations that you can use. That's everything for today. Of course, if you have any questions, please do get in touch. Thanks.